We're doing lesson 11, which is understanding polynomials. Before we do anything that's up here on the board, I want to look at each one of these different expressions. Let's start with this x plus 2. Alright, that x plus 2 has two different parts. As you can see, there are two terms to it, but I want to focus on this 2 first of all. If we change our x, our x is a variable that can stand for anything we want, but we're always going to be adding 2 to that x. So this 2, when you don't have a variable involved, it's not going to change, it is held constant, and that is what the term is for that. That is a constant term. If you look at our other term, this is our 1 out in front. It is an x, we have a 1x, and that 1 out in front of the x also has a name for it. It is called the leading coefficient. Alright, so our constant for this one is 2. Our leading coefficient is 1. If we come down here to this one, alright, if we want to do our leading coefficient first, our leading coefficient is, first of all, you got to put it in the right order from highest exponent to lowest exponent. So that's already taken care of here. If we look at our leading coefficient, that would be out in front of the x to the 4th, which would be a -3. Our constant term here is a little bit different. All of those terms have an x in it, so every single one of those can change. Our leading coefficient is -3, but our constant is like it's not even there. We're not going to add anything to this. So our constant term is 0. So if you don't have a constant term, it's always like you're adding 0 to it. Alright, for what I do have up here is I have that we can classify these polynomials by their degree and by their terms. Degree is kind of like the exponent of each individual term. And what we want to look for is we want to look for that exponent, but not of the number. We want to look for the exponent of the variable. This first one, we don't have a variable. So whenever you don't have a variable, our degree is 0. For our next one, we do have a variable here. We're just looking at that variable. Since we only have 1, we don't have to worry about anything else. It's whatever the exponent is. So that exponent is 1 for that one. If you look at our next one, we have 2 variables. Well, that's fine. They're 2 different terms. We are always looking for the highest term. So we're not going to deal with the x. We're going to deal with the x squared. That is a degree of 2. Our next one, it's all by itself. That's a degree of 3. For our next one down there, we have 3 different terms. They all have x's in it. We're just looking for the highest exponent, so that would be a 4. For our bottom one, we have an x to the 5th and an x squared, just looking for the highest one again, so that would be a 5. We can classify each of these by their degree. Classify always means give it a name. If you think about science, you classify by the different groupings that it's in. They all have different names for that. We can do that with degree also. When you have a degree of 0, that is constant, because it's not changing, just like what we talked about earlier. With a degree of 1, if you were to graph this thing out, this would be a straight line. So this would be linear. And that's what all of these really are. They're classifying by kind of like what their graphs look like. Our next one, we have an x squared. Going back to algebra 1, we know that an x squared is always going to be a parabola either going up or down. That is called a quadratic. And you may remember that from algebra 1. X cubed, well, the cubed gives it away. It is a cubic. Our degree of 4 is a quartic. It's kind of like, if you're thinking about quarts, I believe there are 4 quarts in a gallon. Our next one is degree of 5. which is quintic. You are going to need to memorize these. You're just going to have to get them memorized. After degree of 5, we don't really have any names for them after that, so you do not have to worry about that at all. All right? Plus, I won't give you anything that's over a degree of 5. We can also look at these polynomials by the number of terms. If you look at our first one, we only have one term here. It's just a -4, so we have one term. Our second one, the term is always separated by either a plus or a minus sign. If you look, one of our terms is x, the next one is 2, so we've got 2 different terms there. Our next one, x squared plus x minus 6, there are 3 different terms there. Our next one is 1. Our next one here, we have a -3 and an x to the 4th. This is all one term. Those things are being multiplied together. So that's one term. They're separated by the plus and the minus sign. So 1, 2, 3 terms there. And then our bottom one, we have 2 terms. All right, these also have names so that we can classify them by the number of terms. When you have 1, that is a monomial. When it's 2, just like with a bicycle, you have 2 tires, so it's bicycle. This is 2, so it is a binomial. For 3, just like with a cycle again, when you have 3 wheels, it is a tricycle. Well, this is going to be a trinomial. And then down here we have 1 term again, so that's a monomial. 3 terms is a trinomial. 2 terms is a binomial. Now this is where it can get kind of confusing. If you have more than 3 terms, it doesn't matter if it's 4 or 12 or 17 or 100. After that, they're all called polynomials. I get that this is called a polynomial here, but if you classify it by the terms, it is also, anything greater than 3 is also a polynomial. Next page, classify each polynomial by degree and by the number of terms. Well, if we look at this, first thing we have to do is we should really put this in order by its degree. So we're going to go -3x cubed plus 4x squared plus x. Classify each polynomial by degree. All right, so the degree is 3. Right, we're looking at our highest value there of our exponent. But classify means give it a name. So what was the name that went with 3? That is a cubic. For number of terms, we also have 3 here. So terms is 3. That was a trinomial. Now, if the question also asked what is the leading coefficient, after we put it in the right order, we can definitely see that our leading coefficient is -3. And our constant, we don't have just a number off the end here. Our last one is an x. That's not a constant. It's whatever is added or subtracted onto the end. Our constant would be a 0 for that one. For our next one, we're going to do the same thing. We're going to put it in the right order first. And what I see right away is I've got an m to the 4th here and an m to the 4th here. I need to simplify this. So 1m to the 4th plus 3m to the 4th is 4m to the 4th plus 0.5m. Now that I've simplified that, now I can see, well, my degree is 4, and that is a quartic. And my terms, I have 2 terms, so this is a binomial. So if I were to give this entire equation a name, it'd be a quartic binomial. And then it didn't matter if you're talking to somebody who knows their math, if you said, well, this is going to end up being a quartic binomial, they should know by that that this is going to be a degree of 4, and it's going to have 2 terms. Next one, add these two polynomials together, right, in standard form. Now, standard form means to put it in order from the highest exponent to the lowest exponent. All right, so first it says to add these, though. Now, what you want to be careful of is you want to make sure that you're adding like terms. All right, so what I see here with this x squared, I see 3x squared here and an x squared there. If I add those together, 3x squared plus x squared gives me 4x squared. And what I like to do after I do that is I like to cross them off. From there, I see that I've got 7x plus a negative x. 7x plus x is 8x plus negative x is back down to 7x. And then that is gone. And then everything in my first polynomial is gone. I just need to add the rest of them on there. So this would be a plus 10x cubed plus 2. So then what we need to do is we need to write it in standard form. And that just means rearrange it from highest exponent to lowest exponent. So 10x cubed plus 4x squared plus 7x plus 2. If we were to look at this, our degree would be a 3. Our number of terms would be 4. Degree 3, the name is cubic. For terms of 4, that would be a polynomial. So this would be a cubic polynomial. Leading coefficient is a 10, constant is a 2. So if you put these all in standard form, it's really easy to tell all the answers to those extra questions that we could ask. All right, coming down here, this one looks really similar. We've got a polynomial and a polynomial, except we got a subtraction this time. All right, so same thing as I did before. I'm going to start right here. 4m squared, do I have any other m squareds? No, so I'm just going to write that down. 4m squared. All right, and then I'm going to cross that off. Our next one, we have an m. Well, I've got a negative 3m minus negative 2m. Well, if I look at that, negative 3m minus negative 2m, well, a minus and a minus make a plus, so I've got negative 3m plus 2m. That would be a negative m. Be very, very careful with your signs here. All right, so those would go away. Then I've got a 2 and a 5. Right away, we're thinking, well, I should just add those together. But no, you don't, because we have this minus sign in between. 2 minus 5 is negative 3. So those are all gone. Everything in the first polynomial is gone. I still have this m cubed left over. Well, that's okay. We're going to write that in there. But that would be like saying we have 0m cubed up here minus m cubed here. 0 minus 1 would be a negative 1 m cubed. So that's how you deal with the minus sign there when you have everything out of the first polynomial. From there, we just got to write it in standard form. So negative m cubed plus 4m squared minus m minus 3. All right, once again, this is a cubic polynomial. Our leading coefficient would be a negative 1. Our constant here would be a negative 3. Next page, word problem. The profits of 2 manufacturing plants can be modeled as these different equations here. Write a polynomial expression that represents the difference of the profits. So what this is saying is difference means that we're going to take our first one minus our second one. So 3x squared plus 25x minus 1500. That all goes in parentheses minus negative 0.02 plus 21x minus 1700. All right, and then we just got to subtract those the way that we did on the last page. All right, negative 3x squared minus a negative 0.02x squared minus and a minus make a plus. So a negative 3 plus 0.02, that would be negative 2.98 x squared. So these are gone. 25 minus 21, well that's a positive 4x. And negative 1500 minus a negative 1700, once again minus and a minus make a plus. So negative 1500 plus 1700 would be a positive 200. Alright, so this would be the polynomial expression that subtracts these two out. Alright, there is one more thing that I want to cover with you. Say that we had 4x squared y to the third. That's all one term. What is the degree of that one? Well, what we'd be instantly thinking is, well, you're looking at the highest exponent, right? So you're thinking right away that it's a 3. Well, that would be wrong in this case because what we're looking for is we're looking for the total exponent of the variables in one term. Well, for this one, we would have a 3, but we'd also have a 2. Our degree would be a 5 here. You would just add the exponents together to get our degree. For another one, say we had 2a cubed b to the 7th plus 4a squared b cubed. Alright, which one are you going to look at? Well, what you have to do is you have to find the degree of each one of these. Degree here would be a 10, degree here would be a 5. This one's obviously bigger, so our degree would be a 10 there. You always want to add the exponents together for each individual term. Alright, any questions, please make sure that you see me.